Welcome back, my terrific 7th graders. So glad to have you here today. Today I want to teach you how to use relative frequency to predict the probability of an event. Please make that the title of the next free page in your math notebook. Leave lots of space for our example today. And when you've done that, close it up, clear your space, turn off music, TV, anything that might distract you, and give me your full concentration till we get to the we do. So the word in the title you may not know, relative frequency, has come up before, but let's talk about it. It's a simple idea, but it sounds very complicated. It's a math way to make an easy thing sound complicated. Back in 6th grade, when we talked about statistics, is where we most often saw that word frequency. It's a simple thing. It really just means like how many times did something happen? How frequent was that event? It almost has that word frequent in it. And so like here, this is how many customers came to the store each day of the week. The frequency is just the number of times. So sometimes you see it written like this, 18. Sometimes you see it like tallied, 18. But that's all it means. The frequency that someone came on Monday was just how many times it happened. Relative just means compared to the other days. When we say something's relative, it just means compared to something else. So like the relative frequency, like how many people came Monday compared to Tuesday is all that means. So it's really just a complicated way to talk about counting in math. So when you see that word frequency, don't worry about it. It just means how many times did something happen, how frequent was it. So let's look at some questions and talk about where that comes up in probability. So on a game show, contestants spin a big wheel and they determine which game out of 4 options they will play to win a prize. The game of the last several contestants are shown in this table right here. So 16 got this game, 7 got this game, 5 got this game, 12 got this game. That's the frequency, just how many times did that come up. So you'll notice right off the bat, this is a non-uniform sample space, it would appear. This is experimental probability. This actually happened, right? They counted how many times people played, but it looks like there's not anywhere close to an equal chance that you'll play all 4 games. So this is a non-uniform sample space. So what's the probability a contestant will play throw the darts? So that's this game right here. And again, we're talking about experimental probability today. This actually happened, right? Somebody watched this show and counted how many times each person played, counted the frequency. So we're talking about real probability, not theoretical probability. This happened. All right, so remember, to find the probability of any event, so in this case, the probability of the throw the darts game, is the number of favorable outcomes out of the number of total outcomes, or the sample space, size of the sample space. All right, so favorable outcomes here was 5. The number of people that got that throw the darts game was 5. And the total number of outcomes is not given to us. We have to figure it out, right? So this is all the games played. I don't know how many total games that is. I have to figure it out. 16 plus 7 is 23, plus 5 is 28, plus 2 is 30, plus the other 10 is 40. So it looks like out of 40 total games, 5 were throw the darts. So that's looks like the experimental probability that someone will play that game is 5 out of 40. We can reduce that fraction. Looks like they have a 1 in 8. If we divide both of these by 5, a 1 in 8 chance of playing the game. So there's 4 games, 1 in 8 chance you play that one. Of course, we can also use a calculator and show this as a decimal. 1 out of every 8 or 5 out of every 40, wouldn't matter which one you divided. As a decimal, we would show that probability like that, 125 thousandths, and that is the same as 12.5%. So if you went on this game show and you really wanted to play that game, you have a 1 in 8 chance or 12.5% chance to play it. Next question, using this frequency data, remember just how many times it happened, if the show had a total of 80 contestants instead of 40, how many would we expect to play Throw the Darts? I love this word expect. In probability, we don't really know, hey, if we did this more, would we get the exact same results? Probably not, but maybe, probably close though. So we do this thing where we say, how many would we expect to play Throw the Darts? So if 5 out of 40 played Throw the Darts, how many would we expect out of 80 to end up playing the same game? We have here, we've got ourselves a ratio. And any ratio strategy we care to use would help us figure out how many out of 80 we would expect if we know that 5 out of 40 end up playing it. So I'm going to use the proportion strategy, but we also learned a table strategy, a double number line strategy, a coordinate plane strategy, tape diagram strategy, maybe even some others. I'm going to apply the proportion strategy. So this is a part to whole ratio, the part that played the game out of all the games. So here my whole was 40. If my whole was 80, that's twice as many people playing the game. So I would expect twice as many people to get this game, which is 10. So I would expect 10 people to. Now this is probability. Probabilities not always work out like you think, but I would expect 10 people to play the game. All right, open your notebook. Let's do one together. This is a lot to write, so I'm going to let you pause here, write all this down nice and neat. That way you have a great, clear, perfect example with the questions and everything to look back at later. Unpause when you're ready to go. So what is the experimental probability that a 7th grader at this school plays sports less than 2 hours a week? Remember, this is, of course, experimental probability because she actually asked this. This isn't theoretical probability. So less than 2 hours a week would be these two groups right here. Notice I'm not including 2. It says less than 2. 2 is not less than 2. If it said 2 hours or less, I would probably include the 2 also, but it just says less than 2, so I'm not going to. So remember, for any probability, in this case, the probability of less than 2, probability of that outcome is the number of favorable outcomes out of the number of total outcomes. So the number of favorable outcomes here is the ones I'm looking at. That is 7. Number of total outcomes. Remember in the I didn't know. I had to add these all up. Lucky me, here they tell us how many people she surveyed. She surveyed 25. I'm sure if I add all these numbers up, I'm going to get 25, but I would rather just take her word for it. So the probability of a 7th grader playing less than 2 hours of sports per week is 7 out of 25. I can't reduce that fraction. 7 is a prime number. It can only be divided by 1 and 7. 25 can't be divided by 7. As a decimal, 7 out of 25 is 28 hundredths, which is 28%. So 28% of all of the 7th graders played sports less than 2 hours a week, or 7 out of 25. If there are 1,000 students at the school, what's your estimate, or how many would you expect or predict for the number of students who would say they played 4 hours a week? Woo! Well, let's see. I don't know. Out of 1,000 students, how many would we expect to play for 4 hours a week? Don't know. But I do know how many played 4 hours a week out of these 25 students. That's a good start. The frequency of someone playing 4 hours was 3. So 3 out of every 25 students played for 4 hours a week. So how many would we expect out of 1,000? Now I've got myself a nice ratio and can apply any ratio strategy I like. If 3 out of 25 did, how many out of 1,000? So I'm going to apply my proportion strategy, though any ratio strategy would be fine. Let's see, my whole is now 1,000 instead of 25 in this ratio. 25 times what is 1,000? Going to need some help. Do 1,000 divided by 25. That is 40. So this is like 40 times more students. So this would be 40 times more as well. 3 times 4 is 12, plus there's a 0. So I would expect 120 students to play for 4 hours a week out of 1,000. They use the word estimate. I use the word expect or predict. Any of those words are appropriate with probability. That, y'all, is how you use relative frequency to make predictions in probability. I always ask you at the end, like, if you feel like you've got this, you're good to go. If you don't, watch the video again. Well, how do you know if you feel like you learned this? So some things to ask yourself now. Do you feel like you understand what relative frequency means? Do you think you could look at a frequency table and calculate probability? Can you use a frequency table to make a prediction about a larger group? And do you feel confident about using at least one ratio strategy for probability questions? I use the proportion strategy, though if you prefer another, totally fine. If you can answer yes to these questions, you feel like you're off to a good start with these. We'll finish this up tomorrow. If you don't, go back and watch this again. Have these questions in mind. I guarantee it will help. See you tomorrow.